its eye. Optical lenses are really several lenses combined into a single unit. Together, they recreate an image by bending light rays so they converge into a common point, called the focal point. You get the picture. These television lenses start with a very precise design. A diamond blade slices up a block of specially selected optical glass, while coolant prevents the blade from burning it. The slices then go under a diamond drill, which cuts several puck-sized discs from one glass slice. The operator is careful to keep waste to a minimum. Optical glass costs up to $1,000 per kilogram. During the drilling, the optical glass sits on a thinner piece of glass covered with wax. As the wax is melted, the discs are easily pulled away. Next, a device spins one of the discs while a wheel overhead sculpts it into a lens. The operator checks each lens for chips, and this one looks smooth. This tar-like substance is called pitch. The edges of the lenses have been built up with tape to contain the pitch. They completely coat the underside of the lens with it. Several pitch-covered lenses are now in a metal shell. A worker picks up a hot aluminum dome called a blocking body. He presses it onto the pitch-covered lenses, and the pitch melts onto it. Dousing it with water causes the pitch to harden, sealing the lenses to the blocking body. The blocking body is now upside down and acting as a holding device as it oscillates on a spinning grinding shell. The grinding makes the surface of the lenses uniform and smooth. They place a polisher on the lenses. It's lubricated with a very fine abrasive. For about an hour, the polisher oscillates while the block spins. Polishing makes the lenses smooth and transparent. It also gives them an even more curved profile. The lenses have been removed from the block, and it's time to cut the diameter down to size. Using a microscope, a technician centers a lens between two brass chucks. A diamond blade at the back cuts the lens as the technician monitors it. He's making sure the diameter and axis of the lens have a common center. Next, they group some lenses on round racks called planets. Their universe is a vacuum chamber. The technician closes the door, and the planets continue their orbit. Inside this vacuum, an electron beam evaporates coating materials. The vapor rises to give the lenses a protective coat. A computer monitors the rate of evaporation and the coating. But there's much more to come. Up next, this process really gets visual as all the pieces of a camera lens come together. Along with cameras, you'll find them in projectors, microscopes, laser scanners, X-ray equipment. They give us a close-up view of so many things, it seems only appropriate that we take a close-up look at the optical lens itself. The lenses have just spent 3 hours getting a protective finish. It's time to wipe away any residue and make sure they're perfect. This particular lens is concave. She covers it to protect it while she cleans and inspects the lens with the opposite profile, convex. Then the convex lens goes to another technician who places it in a holding device. He looks into a microscope and adjusts the position of the lens until it's optically centered. He uses wax to keep the lens from shifting in the holding device. They give the lens another cleaning. Each one must be absolutely spotless before they proceed to the next step. Otherwise, dust particles could become trapped within the optical system and affect image quality. Now that the surface of the convex lens is immaculate, she dabs optical cement onto the center of it. She gives the other concave lens a little more scrutiny before she cements it onto the convex lens. She applies pressure to spread the cement between the two lenses. Cementing them together means they'll be less likely to shift around in the lens barrel. She checks for dust one more time. Then it's under the microscope for an optical alignment of this double lens. Because the cement isn't yet dry, he can push the top lens around and adjust its position. Next, they prep the barrel that will hold the lenses. The technician traces out lettering using a stylus, attached to a sharp tool that engraves information onto the lens barrel. It prints technical details that will tell the photographer just what the lens will do, things like focal length, the F number, and the size of the aperture opening. These reference points allow the user to pull a picture into focus at the desired magnification. Now they double-check the design for this complex optical system and begin to pull all the pieces together. This singlet, or single lens, goes into the metal barrel first. Other lenses with various curvatures and dimensions follow. She places metal spacers between the lenses to separate them. Proper spacing will prevent aberrations in the image, such as blurring. Between installations, she covers the barrel with a piece of lint-free plastic because eliminating dust continues to be a necessity. One fleck could ruin this entire assembly. Using tweezers, she coaxes the last lens into the barrel. She installs a retaining ring to hold the stack of lenses down. Then she locks it into place. There's one final inspection. She examines the assembled optical lens from all angles. It takes a total of 6 weeks to make one of these optical lenses, and in the end, it's picture perfect.